Welcome to NASA Edge, an inside and outside look at all things NASA. Today on the show we have Todd White, who is the principal investigator for Medley 2. How you doing today, Todd?
I'm doing well, Franklin.
How are you guys feeling about the landing of Perseverance on Mars?
Oh man, it's exciting stuff. I got to tell you, I obviously have a vested interest in things landing well on Mars, with our sensors being on board Mars 2020, but it's especially exciting to see the incredible footage that's been coming back from those cameras looking down, and just some of the images really puts us there. So it's nice to have the data that we're getting. I mean, that's fantastic stuff, learning about how it performed, but it's just so great to have the images to go along with it.
So as we talk about Medley 2, tell me specifically, what was Medley 2 designed to measure scientifically?
So Medley 2 is really designed to get information about how the Mars 2020 spacecraft performs during those crucial moments during entry. So it's got sensors on board to measure the temperatures close to the surface of the vehicle, both on the front and the back side. So we want to understand how hot things got on the spacecraft. We also want to understand how the vehicle performed in terms of aerodynamically and what the atmosphere was like that it was flying through. So we've got pressure sensors to tell us that. And then we've got some specialized sensors on the back that we haven't flown before that tell us about some questions we had unanswered from the last time that we flew to Mars. So it's those different sensors together, working together, both understanding pressure and temperature. And then taking that information, we can understand a whole lot more about how the entry vehicle worked.
Now, speaking about your last mission to Mars back in 2012, what is the difference between Medley 1 and Medley 2?
Sure. Medley, we call it Medley 1 now. It was just Medley at the time, but Medley was sort of a proof of concept. It was seen that it was pretty important when we're flying these flagship class missions to Mars, that we want to understand how well they do when they're flying to Mars. I mean, in the past, in some missions, we haven't had much more other than we landed and telemetered back. So if something goes wrong during those 7 minutes of terror, as they're sometimes called, we wouldn't really know how close were we to having a problem. How much mass could we save in the future when we're designing these missions by having less TPS or having a tighter landing radius. So Medley was just looking at the heat shield, just the front of the vehicle, and we wanted to understand temperatures and pressures in the hypersonic regime. With Medley 2, we realized we understood the hypersonic aerodynamics really well, but there was some stuff in the supersonic we wanted to understand, as well as winds at lower atmospheres. And then we also realized there was this really interesting phenomena going on that we kind of missed in design, which is that the CO2 gas around the vehicle, when it gets to certain temperatures, it really radiates a whole lot, and that deposits a lot of additional heating on the vehicle. We were fine in terms of our vehicles being safe in the past, but this was basically a phenomenon we completely ignored. And so we wanted to have sensors that could measure that directly, and so we have a couple of those on the back of the vehicle. So it was really taking what we learned from Medley and tuning the ranges that we're going to make those measurements, and also spreading them out much more on the vehicle to look at stuff that we knew was going to be important to future missions.
Through Medley 2, you received good data. Exactly what does good data look like?
Sure. So as the PI, I've said a lot, this is incredibly clean, this is good data. Some people want to know what that actually means. And what it means is, a lot of times we will take flight data from different sources, inertial measurement units, temperatures, other kinds of observations, and you really have to massage and work with that information a while to get what you want out. And what we're seeing with Medley 2, like Medley before, is that you can just kind of look at the raw data that we got back, the raw temperatures, and you can see the stuff that we were trying to go and measure. So one of the interesting things is on the heat shield, there's a couple different things that cause the heat shield to get hot, and different forms of heating. There's convective heating, there's radiative heating. Convective heating is this one where you'll go from a nice laminar flow, and at the point when you transition to turbulence, the heating gets a lot higher. That's happening outside the vehicle, and we're making measurements on the inside of the vehicle, just close to that surface. And we can look at that data, and without any kind of signal processing, we can see these temperatures just skyrocket when you hit transition. We don't have to go and run it back through our models. We don't have to do any sort of thing with it. We can see straight up what it is that we want to observe. Or in the pressure transducers, when we want to look at the vehicle orientations, we can see slight changes of the vehicle orientation just in wiggles in those pressure profiles. We're going to do a lot more in terms of putting this through NASA's state-of-the-art analysis software, but we don't even have to do that just to say first cut. We saw what we were looking for, and so many other interesting things.
Now, since you got this good data, can you say that the measurements and information and data that you received from Medley 2 will help improve future missions to Mars?
Yeah, I think we can definitely say that. We saw that the data before from Medley was used to better understand risks that they had in certain places. I think the same thing's going to be true with this Medley 2 data. So I think we can already say that the models that we use for the designing these vehicles are pretty darn good. We've already seen some areas in which we can improve them, and we're going to see those lessons and those updated models get folded into the immediate follow-on missions to Mars. There's the sample retrieval lander that's part of the Mars sample return program. I can already see that they're going to be able to use a lot of the information that we got, a lot of the data to help make smarter design decisions, both in their modeling of aerodynamics and the aerothermodynamics, so how hot things get. It's kind of neat also to see this information can be used at places other than Mars as well. So a lot of this stuff is the fundamental physics of why things get to fly the way they do in planetary atmospheres with shapes like this. And so this is applicable whether you're going to whether you're going to Earth or whether you're going to Mars or going to Titan. So it's pretty neat stuff.
Well, Todd, I appreciate you being on the show today, and we look forward to getting more data and information back from Perseverance, and we look forward to what you're going to do with Medley 3 down the road.
It's been a pleasure talking with you today. Thanks so very much.
You're welcome. You're watching NASA Edge, an inside and outside look at all things NASA.